So what are the challenges? Okay, long documents. This is one of the prominent challenge we face in designing a RAG for production. So obviously we have very long documents. If you take any financial document, it will be like analyst report or any other related to finance. It will be at least 100 to 200 pages. Some it goes beyond 200 pages. Now, how you can deal with these long documents? That is a big question here. So relevant information is diluted, making it hard to find precise answers in lengthy text. Like for example, if a user asks a typical question where it has to search through different documents, like starting some part of the question will be in the middle of the document, some in the end of the document. So it has to search through, like then definitely the LLM will fail to give you a correct answer. So that is one main reason where the RAG application will fail. So here the key solution and techniques what we can do is that for long documents, especially the chunking. So the chunking is a process where you split the long documents into smaller manageable chunks, and then you can feed it to the LLM for embedding. You can't feed as it is like the entire document to do the embedding, right? It is not possible. So you have to split the document into chunks. But how you are going to split? There are different variety of methods how you can split the document into chunks. So one is sentence. You can split the document based upon the sentence or a paragraph. Fixed size, like irrespective of whatever, even if the context overflows the next chunk, you doesn't matter. You give you a fixed size and it will chunk everything. Or semantic. So semantic means you see that a semantic context within like you differentiate the chunks based upon the semantic meaning. Like for example, if one particular paragraph says or a two paragraphs says a specific meaning for that document, then you take that particular thing as a single chunk and put it, because you are not splitting those chunks. It contains the semantic meaning of the entire what they are going to mention. Like so that is one way where you can do the chunking. So it depends upon your processes, like your business use case. So you can't do semantic chunking for which is totally different, where you don't need a semantic chunking, and for some reason you need a semantic chunking. Like you should not spill over the context to a different chunk, and then it is very difficult for LLM to retrieve both chunks in a given order such that it can answer the question. So that trade-offs you have to make sure, like which one you want to use and which you don't want to use. So that makes a crucial decision while doing retrieval. This we will see like the next one, which is query document mismatch. So what is query document mismatch? This is a typical scenario where most of the RAG pipelines also fail. So let us see what it is actually. So here the user question is phrased differently from the information in the document. Okay, so that is the main thing. So user asks a question which cannot be semantically or which we cannot able to retrieve a specific document to answer the question. So let us assume give an example here. The user asks the question: did XYZ company report any impairment losses in Q4 2024? This is the user question asked. The relevant document, which is from 10K filing, we have it here in the document database, our vector database, is in the fourth quarter of 2024, XYZ recognized a 12 million write-down on its goodwill related to the MediaTek acquisition, citing underperformances and revised forecasts. So this is the actual the chunk we need in order to LLM to answer that particular question. So what happens here? The user is searching for impairment losses, a specific accounting term, but he didn't mention that one specifically in the like in the given document chunk. It is mentioned of write down. So the document refers to write down on goodwill, which is impairment obviously, but the term impairment was not mentioned in the document. So this semantic, even with the semantic check, this mismatch may occur, because either you should train the retrieval LLM in such a way that it will understand the financial terms. Then you can able to solve this problem. So these are the typical nuances when we have a RAG pipeline. So first one is long document, second one is user query mismatch, and then the simple. So now you can see like the domain specific jargon plays important role. Like for example, if it is a finance domain, the embedding model as well as the LLM has to understand the domain specific concept. Then only you can able to retrieve the correct documents. So general models fail because they are not trained on a specific domain. Like specialized vocabulary example, you can see that impairment loss, it is semantically like it is equivalent to write down. So that matching has to be done by the LLM. So until unless it doesn't know those meanings, then it cannot able to match. So for that, what we can do, we can fine tune a smaller model to do the task such that you can fine tune your own corpus or in financial domain, or you can pick a LLM, a small LLM trained on a financial domain and use it for your business use case. So in just that, like where it can able to understand the user query and get the correct documents. So that's one thing. So custom embeddings, use embeddings trained on domain specific text. Fine tuning, adapt, that's what I mentioned, like you can fine tune a smaller model and then based upon your own document data. And hybrid search, a combination of keyword and then semantic. So this also helps. You are not only using a semantic, you can also use keyword search and combine the results and feed it into the LLM. So that's one thing. And also you can use re-ranking. So that we will discuss later the videos, like how you can do re-ranking. Apart from getting the chunk, you can also re-rank the chunks and then pass it to the LLM so that it will give the correct answer. The next typical problem here is complex formats. Especially if a document contains, let us assume there is a PDF document, analyst report given to a particular company. Like now those analyst report contains a lot of tables, images, and then charts, graphs, whatever maybe. So everything aligned, or you can see the images in one side and then some text and then tables. So these things, like it is a very complex document, then that needs to be retrieved, or you want to process it, then it will be very difficult, like because you not only like just parsing the document, or extracting the text, you need to scan the images and also get that information from that one. So if you take a model, OCR model, where it can able to get the images, but it will extract the text, it will fail in images, like especially a typical chart which shows something like year over year increase or something like that, whatever it may be. So it may fail. So if it fails in the first stage, then definitely you are not getting the answer for that particular question asked on that particular image. So that's why we need a multimodal retrieval, where we use vision models to extract text and structure from the images and then pass it to LLM. That's one thing we can do. On the integrated stage, combination of visual and textual data for comprehensive results. So you can one thing you can do is that you can, if for example you have a analyst report containing images, graphs, charts, and all those complex format in a PDF. So you pass it to LLM. So one pipeline where you can do is that you can do a normal OCR and extract all the text and then put it in a vector database, and then you can convert each page in a image and then pass it to a multimodal model like Google Vision model and get the description and store those images in a database with the metadata of those description. Okay, so now we have two different pipelines, one having a regular RAG pipeline, data pipeline, and another having a image pipeline. Now when a user asks a question, we can get these both combined, like you can get all the relevant document chunks and then as well as the RAG pipeline which process the images, both pass it to a multimodal LLM, and then that it will give you a most precise answer compared to only having text only RAG pipeline. So that's one thing I want to mention here. We will continue in the next video.